Hi everyone, this is Math 176 and this is your introductory lecture video to section 6.5, the law of sines. So before I even get started with this section, there is some notation that you will have to get used to. This notation is also in the textbook. In this section, section 6.5, and the next section, 6.6, we're going to be solving triangles. And the sides of the triangles are denoted by lowercase a, b, and c. The angles of the triangles are denoted by capital A, B, and C. And these angles, capital A, B, and C, these are the angles opposite of lowercase sides A, B, and C, respectively. So when it comes to solving a triangle, you are finding all the sides and all the angles of the triangle. The triangles that we're going to be dealing with in these two sections, they're not necessarily going to be right triangles. Most of them will not be. Your textbook talks about 4 cases being presented for triangles with some given information. In section 6.5, you're going to be given triangles that fall into one of 2 cases. Case 1, you are given one side and you are given 2 angles. So you know explicitly one side and 2 angles of a triangle. The second case, case 2, you are given 2 sides and you are given an angle that is opposite one of those sides. For the triangles in cases 1 or 2, the law of sines is used to solve these triangles. What is the law of sines? The law of sines basically states the following. If you look at an angle and the side opposite that angle, the sine of that angle over the side opposite that angle, this is always equal to the sine of another angle divided by its opposite side, or the sine of a third angle divided by its opposite side. All of these ratios here are equal to one another. Normally in my classes, I would go through a proof of the law of sines and also in the law of cosines for the next section. But these are just introductory videos. And right now, with where we're at in the class, I just want to focus on getting the information out there. So this is the law of sines. If you're interested in seeing a proof of this, I would recommend that you read your textbook. This section, once again, is section 6.5. So here's an example of a problem. You are asked to sketch a triangle with the given information and to solve it. Once again, to solve a triangle, this means you need to find all of the angles and all the sides. So in this problem, you're given angle A is 50 degrees, angle B is 68 degrees, and little c is 230. So you're given angle A, angle B, that's the 50 degrees and the 68 degrees. So the side opposite angle A is little a, the side opposite angle B is little b, and the side opposite angle C, this is going to be 230. So right off the bat, you know that all of the angles, when you add them up, all of the angles inside a triangle, when you add them up, they must add up to 180 degrees. Scrolling down, this tells you that the angle, capital C, is 72 degrees. So now that we have found all of the angles of this triangle, we must find the sides. How are we going to do this? Let me go back to the law of sines. For a triangle, if I look at the sine of an angle divided by the side opposite that angle, this ratio has to be the same no matter which angle and which side opposite that angle I look at. Going back to this problem, you now have angle C and the side opposite angle C. So I must have the following. Let's take a look at the purple. The sine of angle C divided by little c, that's sine of 72 degrees over 230. This is equal to the sine of angle A divided by little a. From here, you can cross multiply to solve for little a. So cross multiply and then isolate little a. And then you will have to punch this into your graphing calculator, this ratio here. I did the same thing here in the green to find little b. The sine of 72 degrees over 230 equals the sine of angle B divided by little b. And I plugged in that given information, right? Because we found angle C, you were given angle B, etc. From there, you will isolate little b and plug in this ratio into your graphing calculator. So just to be clear, I did in fact round my answers here. So let me go to the graphing calculator so I can show you how I found one of these values. Let's look at little a. Little a is 230 times sine of 50 degrees over sine of 72. So give me a second here. Ooh. So unfortunately, I can't move this recording screen. Oh, no, I can. Okay, cool. So I have 230 multiplied by the sine of 72. And this is divided by the sine of, let me go back to the problem really quickly. Oh, I messed that up. I'm going to have to do that over. Let me go back to the problem. It was 230 times sine of 50 over sine of 72. 230 times sine of 50 divided by sine of 72. I'll hit enter. And then I had rounded to the nearest whole number. Okay. That takes care of this lecture video. I will see you in tomorrow's Zoom meeting.